It covers the general characteristics of waves, the electromagnetic spectrum, and sound and ultrasound. First, some general facts about the characteristics of all waves. Waves carry vibrations. They carry energy locked up in those vibrations from one point to another. One way of understanding waves is to look at water waves. When we throw a pebble in a pond, waves spread out in all directions. The energy of the pebble is transferred to the wave. The energy makes the water vibrate up and down. The waves carry the energy to the bank. You can set up a wave in a rope by moving one end from side to side. Side-to-side motion like this is called a transverse wave. The vibration is at right angles to the direction the wave travels. A slinky spring can carry another kind of wave. If you push and pull the end of the slinky, you get compression and expansion of the spring. This is called a longitudinal wave. The vibration is in the same direction as the energy is travelling. The wavelength of a wave is the distance from one crest to the next. The symbol for wavelength is the Greek letter lambda. The amplitude of a wave is the height from the midpoint to the crest. The frequency of a wave tells you the number of waves passing a point each second. The unit of frequency is the hertz. You can calculate the speed of a wave. The speed of a wave in meters per second is equal to the frequency in hertz times the wavelength in meters. That's V equals F times lambda. All waves, including electromagnetic waves, also have the properties of reflection, diffraction, and refraction. Look out for these properties in the next clip.
Now, in order to understand the properties of electromagnetic waves, we need to look at waves which we're more familiar with.
Water waves have the same properties as electromagnetic waves.
Here we're able to look at the waves in a more controlled way. A small electric motor agitates the water, generating what are called plane waves. A property of waves which is easy to take for granted is reflection. Here we can see the plane waves approaching the surface and being reflected. A less familiar property of waves is that they can bend round corners. This property is called diffraction.
All waves have the same basic properties. Although we can't see electromagnetic waves, we can show that they diffract in the same way as water waves.
Light is also refracted, that is slowed down and bent, when it passes through a different medium like this glass block.
With light waves, a prism slows down the different colours that make up white light by different amounts. The blue light is slowed down more than the red light, and so it's bent through a greater angle. There's another very important feature of refraction. As you increase the angle at which the light strikes the block, so the wave is refracted more. Eventually, beyond a certain angle known as the critical angle, all of the light is reflected from the surface. In other words, it acts just like a mirror. This is known as total internal reflection.
Reflection is the change in direction of a wave when it bounces off a surface. Diffraction is the change in direction of a wave when it passes close to the edge of an opaque body or through a narrow slit. Refraction is the change in direction of a wave when it passes into or out of a different medium. Waves can also be absorbed when they pass into a different medium. That's it for the characteristics of all waves.